Okay, my friends, we are going to be working on lesson 28 and 29 today, or tonight, or this morning, whenever you're doing this. Our aim is solve division word problems involving multi-digit division with group size unknown and the number of groups unknown. So this is multi-step division. And I'm combining lesson 28 and 29 because they both have the same aim. Both lessons are word problems. So what I'm doing with you here is basically the problem set for lesson 28. All right, so let's just get started. So we're going to be doing tape diagramming, and although it's not our favorite thing, it actually works well for these word problems. So I've gone ahead and I've done all of the drawing just to save us time, since as we know I have 15 minutes to do these recordings. So here we go. Ava is saving for a new computer that costs $1,218. She has already saved half the money. Ava earns $14 per hour. How many hours must Ava work in order to save the rest of the money? So here's our tape diagram. And as you can see, the total diagram is $1,218. So she's already saved half. So that would be, let's see if this allows me to do a dump. Nope. Okay, never mind. So this half here, okay, is what she saved. Okay, so that's the difference. This is how many $14, how many hours did she have to work? Okay, that's what we're looking for. So we take the $1,218 and divide it by 2. Okay, because half of it she saved, half of it she needs to still work. So what is 1,218 divided by 2? That is $609. Okay, so she's got that done already. So that is where I got this number from. Okay, do you see that? She has this saved. This is here. Now we need to know how many more hours does she need to work. So we need to do this division. So you go ahead and do the division, and I will do it, and we'll see if we agree. Okay, so did you get 43 and 5/10? Because that's what you should have gotten. So you started with the whole number 609, and as you divided, you had a remainder of 7. We can't have remainders, so we need to add another 0 at the end. So we place our decimal point here, right up here, add our 0, and bring it down until we have 0 as the remainder. We keep working it out, keep adding zeros till there is no remainder. So she needs, Ava, our friend Ava, she needs to work 43 or 43 and 5/10 hours, or you can say 43 and a half hours, whichever floats your boat. Okay, so that's number 1. Moving on to number 2. Michael has a collection of 1,404 sports cards. Whoops. He hopes to sell the collection in packs. This is going to bug me. Hold on. He hopes to sell the collection in packs of 36 cards and make $633.75 when all the packs are sold. If each pack is priced the same, how much should Michael charge per pack? Okay, so here's our information. We have 1,440 sports cards, 1,404 sports cards total. Okay, so that's our whole tape diagram. That's our whole bar. He hopes to sell the packs in 36 cards. So we don't know how many packs with 36 cards per pack. Okay, so do you guys understand that? So in each of these little sections would be 36. So let me make that clear. So this is, So this is 36. This is 36. And you keep going, and there's 36 in each section, but we don't know how many sections are there, right? Okay. So when all the packs are sold, he wants to make $633.75. That's his goal. Okay. If each pack is priced the same, how much should Michael charge per pack? So this is where I am going with, you see these numbers here and you're wondering how I got them. Well, the first thing I'm doing is the total number of cards, which is 1,404, and he wants to sell them in packs of 36. So that's where I got this from. Total number of cards divided by cards in a pack equals how many packs. Okay, so go ahead and do that. Come back and see if you have the right answer. Okay, so if you worked out the division, long division style, you would have ended up with 39 packs. Okay, and that's where this number came from. Okay, so the quotient here is 39, and that's this. Same thing. Okay, I just wrote it in a different way. So now we need to do the division here. Okay, so I'm going to do this one with you. So $633.75 divided by 39 packs. So 39 times 1 is what I'm going to use. Oh, this is ugly. Is 24. Bring down my 3. Bring up the decimal point is 16. Is 234. Subtract is 9. Bring down my 7. 97 divided by 39 is 2. 2 times 39 is 78. Subtract is 19. Bring down my 5 is 195 divided by 39 is 5. 5 times 39 is 195, and I'm done. So he should charge $16.25. Oh, brother. $16.25 per pack. Okay, so does that make sense? It should. It's pretty straightforward. It's just a couple of steps. So total divided by cards per pack gives you number of packs divided by how much money he wants to make, and that's how much he should charge. All right, moving on. Hey, I went the wrong way. Sorry. Okay, this one looks a little bit more complicated. So, you know what? Let's not look at this right now. Let's just look at what the words say, and then you can look at all my work. Jim is building a treehouse for his 2 daughters. He cuts 12 pieces of wood from a board that is 128 inches long. He cuts 5 pieces that measure 15 and 75 hundredths of an inch each, and 7 pieces are cut evenly from what is left. Jim calculates that due to the width of his cutting blade, he will lose a total of 2 inches of wood after making all the cuts. What is the length of each of the 7 pieces? So what we are actually looking for is this. That's what our goal is to find out. So my tape diagram that I gave you represents the hole, okay? The hole is 128 inches. That's where I get this from. He cuts it into 12 pieces. Okay, but before I do that, 5 pieces measure 15 and 75 hundredths of an inch. So I did the 5 pieces here, And I know they're 15 and 75 hundredths of an inch each. So I did this. Okay, and that's where I got the 78 and 75 hundredths from. I have the total 128 inches here, and this little section is my 2 inches, which is extra. He said he will lose 2 inches, so that's this part. So that's 128 inches minus 2 inches equals 126 inches total. That's what I'm actually working with, if you think about it. Okay, I'm working with this piece here now because the 2 inches is useless. It's gone. All right, you following that? So 128 inches, what we started with, minus the 2 inches that are going to be lost, so lose means subtract, gives me 126 inches in total that I'm working with. I know these 5 pieces are 15 and 75 hundredths of an inch each, which will give me a total of 78 and 75 hundredths of an inch for all 5 pieces. My next step is I take the 126 inches that I have up here, okay, because that's the total number I'm actually working with. I bring that down here. I subtract out the 78 and 75 hundredths of an inch to find out the total of these 7 pieces. So these 7 pieces equal 47 and 25 hundredths of an inch all together. But now I need to know how much each piece measures. So I take that 47 and 25 hundredths inches, and I need to divide it by those 7 pieces. And I do my division, and I end up with 6 and 75 hundredths of a piece each. So the length of the 7 pieces is 6 and 75 hundredths of a piece, of an inch, each piece. Okay? Do you guys follow that? You kind of have to watch this one again if you get confused. This is the problem that has the most parts, and that's actually where I'm going to stop. So that is your problem set for lesson 28. Okay, so you're going to work on some homework problems at home. I'm looking through them right now. There's 5 problems on the homework sheet, so I will decide which ones I should give you to work on along with watching this video. I'll probably just give you 2 and we'll do the rest in school. And then we're going to work on lesson 29 together, and then it's review time because the test is on Thursday. Okay, so if you don't understand these word problems, you need to come to class with questions. The tape diagramming is not necessary, but it really helped me to understand what I was doing and what I had. So for division, you might want to try to use the tape diagramming. I really think it's beneficial. And all along, I've kind of been agreeing to say it's confusing, but right now I think it really helped me to figure these out. All right, so good luck. I know you can do it. Take it slow, step by step, no rush, and try to check yourself to know that you are correct, which I'm sure you will be. I have all the confidence in the world in you guys. You're smart and you could do this. All right, just take your time, no rushing. All right, guys, see you in the morning.